Hi, I'm Nick Kellett. I'm the founder and CEO of Deploy Solutions. We're a Canadian software company that specializes in building applications that use big data, including data from space. Today's topic is New Horizons in Space Apps Development. Before we begin, Deploy Solutions is a Canadian software company, and we increasingly build solutions for the space industry. Some of our ongoing and recently completed space-related projects include an Earth observation pipeline in Amazon Cloud, which we built as a subcontractor for a Canadian government client who needed an automated push-button solution that deploys a complex Earth observation processing pipeline in the Amazon Cloud. Cloud to LEO pipeline, which is an R&D project we're working on with some Canadian and European new space partners, which will standardize the way code and data is deployed from Amazon Web Services Cloud to satellites in LEO. And climate change action platform, which is an R&D project using geospatial data to help citizens avoid, adapt to, mitigate, or recover from climate change impacts and disasters. We also sponsor and help organize the Space Apps Ottawa annual hackathon, which I'll talk about more later. And you can learn more about our work at www.deploy.solutions/projects. And briefly about me, I'm the founder and CEO of Deploy Solutions. I'm also the lead organizer of Space Apps Ottawa Hackathon. I'm a programmer, technologist, speaker, and instructor with over 20 years of professional experience developing worldwide. I've been blogging since 2006, and my latest blog is at blog.nicholaskellett.com. And last but definitely not least, I am passionate about travel, space exploration, and building great software solutions. So the title, Why New Horizons? Well, it's a metaphor for looking ahead to where we need to go. But it's also a tribute to one of humanity and NASA's greatest achievements, which is the New Horizons flyby of Pluto. It crossed a vast distance in only 9 years with perfect execution to achieve great things. And that's the kind of goal we should set in our lives and work. And just to put this in perspective, over here on the left, we have the image of what we knew about Pluto in 2006 when the New Horizons mission launched. And this is what we knew in 2015. So again, I think this is a great metaphor for what we're trying to accomplish. And we'll talk about that some more today. So let's set the stage and talk about the changing space data landscape. There are a number of emerging trends in the space industry. Overall, the global space economy is valued at $330 billion currently, but is predicted to grow to $1 trillion to $2.7 trillion, depending on who you ask, by the 2040s. And with that is obviously a lot of increased investment activity. In addition, the satellite launch market is trending upward. The small satellite market may reach $62 billion by 2030. The demand for small satellite launches for new constellations and replacement missions is estimated to be about 11,000 or more by 2030, according to Satellite Today. And Euroconsult sees 3,000 satellites over 50 kilograms, including 23 constellations, launched by 2026. Naturally, if there are more satellites being launched, there's more Earth observation. So the market trends there are that the satellite-based Earth observation market may reach $7 billion by 2023, with an annual growth of 14% to 2020. And the EO data itself is projected to have a 23.5% compound annual growth rate by 2028. And some other market trends emerging, obviously, is not so positive: COVID-19 and climate change. So environmental, health, socioeconomic, and political disasters are growing in frequency and severity. COVID-19 shock on the global economy means businesses and governments will have to do more with less. Climate change disasters are increasing in impact and severity, along with awareness and activism accordingly amongst the public. And space data can obviously be used to help monitor and mitigate some of these adverse impacts. And in fact, it may be a key ingredient in tackling some of these problems in the world. So overall, if we look at all these trends and these impacts, we see a rising tide of data from space. All of these market forces mean that more EO and space data is available to store, analyze, and share. The data is becoming real-time or near real-time. There is increased urgency to use it. There are more downstream end-user business needs to be met. And ultimately, there's increasing pressure to provide information and value-added services and products rather than just raw data. All right, and so what's a space app? That's the other part of our title. It's a term used by space agencies such as NASA for the International Space Apps Hackathon that they hold every year. There is no formal definition for a space app, and the one we use is as follows. It's a software application that uses data from space to achieve business goals and objectives, and it has certain characteristics. It always includes data from space. There's an emphasis on rapid development, solution hacking, creativity, and innovation. There's a focus on the end user experience and adoption of the solution. The solution itself is mostly or entirely open source, and it would generally be considered to fit in the downstream or even end user segments of the space industry value chain. It's important to point out that data, although it has to include space data, doesn't have to be limited to that. It's often hybrid. It's paired with other data sets that are not from space. And I think you can imagine, if you look at these definitions and these characteristics, that many of the software applications that you've built or you have worked on or that you use would actually be considered space apps. And we've got some examples of the kind of thing that a space app could do based on work that we've done, things we've seen, market research that we've performed. So a space app could use satellite Earth observation images and Internet of Things sensor data to observe remote pipeline health. A space app could apply multi-temporal analysis on EO images to quantify climate change impacts. Information could be extracted from UAVs, and high-resolution imagery can be used for monitoring industries such as construction and agriculture. Automated extraction of ground deformation trends can be used by risk assessment experts, insurance sector people, civil authorities, and engineering firms. Another example of a space app could be the use of RCM, Landsat, Sentinel-1 data for monitoring flooding and ice breakup. And finally, we could use traffic patterns and atmospheric sensor observations to correlate with COVID-19 infection rates. That could be presented as a space app. So there's a wide variety of use cases, and again, it would have to meet this definition and this profile, and then it would certainly qualify. All right, so we talked about the NASA International Space Apps Hackathon. What is that? It's the world's largest hackathon. It began in 2012 with a variety of goals, but effectively it arose because NASA realized that they had a problem. They had this enormous amount of data from all their different missions, but they weren't able to use it effectively. They did not have the resources to realize the potential of the data that they had at their fingertips. And they recognized there's an opportunity to make this data available to the public, who could then help them in this problem. And they knew that people love to hack. They like to solve problems using data and using software in many cases. And they'll do it in their spare time for free. So they started to run a hackathon. And the way that that generally works is it's a time-limited event, usually held in a single physical location. In the case of the NASA Space Apps Hackathon, it's actually in cities around the world. And increasingly, and certainly this year because of COVID, it can be held virtually. Ultimately, challenges are posed by organizers, sponsors, or participants. The participants form teams to tackle the challenges, and then they hack solutions which are open source. So why would you get involved in a hackathon as a participant? Well, it's a chance to learn about and help solve real challenges. And especially in the space industry, which can be a very difficult industry to get into, it's actually a great way to learn about some of the challenges that are faced within it. It's also a way to have personal development, professional networking opportunities, and last but definitely not least, to have fun and enjoyment. Why would you get involved as a sponsor or organizer? Well, it can increase brand awareness and outreach. It can give you hiring opportunities. It can allow you to get feedback on the use of your tools and your product if you put them in the hands of the participants. And so this is a very beneficial thing for many companies. And these are examples of NASA challenges. So you can see some categories range from challenges around the Earth's oceans to challenges around the moon to challenges around the planets in our solar system. And if you looked at any particular challenge category, you might see something about creating drones or something about observing the planet or observing the atmosphere. And these are all examples where a participant would take NASA data, publicly available data, and actually try to solve a particular challenge with it. So this has been wildly popular. It began in 2012, as I mentioned, with 2,000 participants, 25 locations in 17 countries. And last year, there were 29,000 participants in 230 locations in 80 countries. This year, it's going to be an online event that will probably assist with participation rates, but it's obviously impossible to predict what those numbers would look like. But these are definitely big numbers, and certainly it's been growing year over year. Now in Canada, The early history of the Space Apps Hackathon involvement is actually surprisingly difficult to figure out. I tried to put a history together a year ago, and I really struggled to do it. We know that the early events were really just the NASA event versions happening in a particular city in Canada. We think it began in Vancouver and Montreal, and subsequently it went to Toronto. But again, the early history is very hard to pin down. But we do know that starting in 2017, the Government of Canada became involved, particularly the Canadian Space Agency. And they actually set some challenges that participants could take using Canadian space data. And so we know from 2017 onwards, we have hard numbers. We went from 200 total participants on these Canadian Space Agency challenges, or hackathons, and 30 participants on the challenges, to 173 participants on CSA challenges last year, out of a total of 600 Canadian participants. So the numbers are small, but they're growing. And why does the Government of Canada do this? Well, there's actually many departments that are involved in supporting the Space Apps Hackathons in Canada, but the Canadian Space Agency is the primary federal organization, and I would say that Natural Resources Canada works very closely with them as well. Why is the CSA involved? They've told me that they want to raise awareness of the CSA mandate and missions. They want to provide educational outreach on the missions and actually expose Canadians to the availability and use of space data, such as Radarsat, RCM, NEOSat, and so on. In the 2020 Open Government Roadmap, objective number 5 was open science, and the CSA also believes that these space app hackathons are a good way of promoting that, and they feel that it's a way of promoting STEM careers, particularly among traditionally underrepresented groups. And examples of CSA challenges in the past include the one on the left, which was to help Canadians visualize and interpret radiation data collected by astronauts David Saint-Jacques, Chris Hadfield, and Robert Thirsk on their missions. And the one on the right was an example challenge about making it easier to consult stratospheric data that was collected by a balloon. So Space Apps Ottawa is our Ottawa version of the NASA International Space Apps Hackathon. We're now in our 4th year. We've undertaken a recent rebranding to emphasize the dual nature of the event, which is NASA plus CSA participation. It's hosted and strongly supported by Dr. Stephen Muja and Carleton University's Technology Innovation Management program at the university. The participants are usually university students or recent graduates and young IT professionals. Our goals include gender parity and increasing engagement from youth and traditionally underrepresented groups. And you can find out more details on www.spaceappsottawa.com. And again, I personally am one of the lead organizers of this event, and Deploy is one of the sponsors, but there are many other organizations and people involved in this than ourselves. All right, we've talked about the market drivers. We've talked about what a space app is and the history of the Space Apps Hackathons. Now, what can a space app do, and how do we build one? Well, let's start with a sample that was actually produced by myself and several other people at last year's Space Apps Ottawa event, called Radarsat 1 Liberators. And the idea was it's like Realtor.ca for Radarsat, a prototype space app that could connect to EODMS, which is an Earth Observation Image Management System, and position Radarsat 1 image locations and metadata on a world map. And this in turn would allow the end users to easily view and filter against the whole EO dataset. And they wanted to do this because they had to make decisions about the optimum use of imagery digitization in order to make the data usable, but they had images all over the place. And so this was a way of visualizing what was out there so that people could make decisions about what to digitize. And Kevin Jones wrote a great article on GoGeomatics called Hacking to Liberate Radarsat 1 Data, which you can see at that link there. And it's actually a very good explanation of how a hackathon works and what some of the advantages are and what that kind of experience is like. So I definitely encourage you to read that article. I think the important point here is you can see a screenshot of the user interface, which is very simple and intuitive for an end user. It shows available Radarsat imagery over a map. You can scroll around and view different locations of the globe. And if there's imagery available, it will appear. And what's interesting is you can then filter very easily between some of the Radarsat metadata, such as beam mode, and so on. But under the hood, in order to produce this, there's a whole bunch of complex stuff going on, and we're going to talk about that a little later. But it's important to note that although it looks simple and easy on the surface, it's actually deceptively difficult to do this. All right. Taking a step back, what are some of the differences between space apps and regular applications? So in a regular application, the principal data does not come from space systems. Well, in a space app, it does. In a regular application, the principal data may not even be geospatial at all, but in a space app, it usually will be. In a regular application, the raw data is already analysis ready, but in the case of a space app, you need to do additional data gathering and processing to get it analysis ready, or you probably do. And another main difference, again, in terms of the data, is that the data sets will often contain millions or billions of very small records that are human readable, usually in text format, in the case of a regular application. Whereas a space data set, at least at the moment, may only contain a few thousand records, such as Earth observation image files. And they may be completely non-human readable or not obviously human readable. And their size might be 50 to 100 megabytes each per one of those files, whereas a record in the case of a regular application might just be a few kilobytes, or even just bytes. Some of the other differences in a regular application, it's very common to have cross-industry data formats that are accessible to lay people. Most end users are not scientists or engineers. Software tooling and technical support is widespread across the industries, and technical knowledge is therefore easily portable. In the case of a space app, data formats are often unique to the space industry, and they're often highly scientific. Many end users are actually scientists or engineers, and therefore software tooling and technical support may be very limited and niche. And as a result, technical knowledge may not be as portable, and there may be high ramp-up time to get somebody building a solution on that kind of data format. So just to put that in perspective, we can see here some example of the two data types. On the left-hand side, we would have a Radarsat SAR image in GeoTIFF format, about 56 megabytes. And that is an example of a data point that would be available in a space data set. On the right-hand side, we have a CSV file of, in this case, city data, which is almost 30,000 items, but only about 3 megabytes. And you can see that as a human, you can readily read it. So if you gave the CSV file to an average developer, they would immediately know what to do with it, and they would have thousands of development tools and articles on how to make the best use of it. If you gave an average developer the GeoTIFF image, good luck. Another thing that a space app would usually have is a data processing pipeline, because again, they revolve around the use of data. And so common steps that that pipeline would have to accommodate would include collection, consolidation, analysis, packaging, and long-term storage and disposition. You can see in the diagram that there's an example where we have some telemetry data from a satellite over in step 0 there that would be collected and consolidated and processed and analyzed, packaged for distribution, and ultimately would be stored for long-term use or potentially disposed of eventually. And that is the flow. This is often a pipeline that, like this, would also be present in non-space apps, but the difference would be in the complexity and the size and some of the needs based on the different data formats. If we were to look at an example space data workflow in a little more detail, a client will usually define their original data format, which is called the schema, and how it will be modified for reporting and business needs. This is called a mapping or an ETL mapping. A processing service of some kind will have to convert that source data to the desired state using those mapping rules. That service will then bring the data into a location where it can be reported on, such as a data warehouse, where AI algorithms and human data scientists may shape the data further. The business end users will view the enhanced data in their visual reports or embedded in web applications or perhaps in a map. They will probably provide some feedback that must be then used to improve the AI models and analytics. And ultimately, usually the client will want to publish an analysis-ready data or a value-added product or to a hosted location where their fellow staff, their partners, or their customers can get access to it. Another example of a common need in a space app is report visualization. So data scientists and stakeholders may want to visualize hybrid data. They may want to securely access it from their desktops, and they will want to use standards like ODBC, JDBC, OData, WFS, and so on. This relies on having a secure, scalable data storage and lifecycle management infrastructure, and also integrating with third-party tools. And finally, we have an example of some packaged data products and how that workflow would work. So again, space app users work on their data. They produce a production-ready data package. They choose a publishing destination. They would set commercial terms such as pricing, licensing requirements, and so on. They would publish the package, and then customers and partners access and download the packages. So these processes that we talked about would be pretty common in most space apps. But it's actually very complicated to do all of this. So it turns out we also need a good infrastructure that can support it. We need servers, we need databases, we need a secure workstation access, auditing and logging, firewalls, machine learning and artificial intelligence algorithms, and we need data collection, transformation, image processing, publishing, scripts and processes, and a whole bunch of other things just to make any of this work. And that's why I was saying earlier when we looked at the example of the Radarsat 1 Liberators, the user interface, which is so important from a user experience and adoption perspective, actually belies the complexity that's happening under the hood in order to achieve that. And this is a characteristic, I believe, of space apps in particular. All right, so how space apps are currently built? Well, there are many standard software components and data formats that are available, and I mentioned some of them. But for the space app as a whole, it's custom development from scratch. And that's a challenge, and I'm going to explain why right now. So first of all, with custom development, you have project challenges. And globally, about 70% of software projects fail because they go over budget or over schedule. They have missing features. The users don't like the features that are available, or they even have a catastrophic failure and they never even launch. There are also data-related challenges. So data preparation is about 80% of data science work, and obviously it's very complex in the case of space apps, which could use very scientific data. There are people-related challenges. Often there's a lack of knowledgeable experts who can work on these types of problems. And if they're working on a project or a couple of projects at the most, they can't work on anything else at the same time. So it's a challenge to find the right staff who can do this sort of work. There are process-related challenges. So big data and AI technology fields are complex and they're rapidly evolving. Digitalization initiatives are impacting most organizations simultaneously. There are growing privacy and sensitive data needs and cybersecurity concerns. And overall, with any application, you need to be concerned about governance, compliance, risk management concerns and issues. There are some technology-related challenges. There's constant disruption and reinvention occurring right now. And there are technical limitations and constraints to some of the technology choices that are in use. And ultimately, there are also budget challenges. So we put together a little table of the roles that we believe are needed on a standard space app. And if you look at that at a 3-month, 6-month, or more likely a 12-month schedule, based on the salaries that are available for these roles in Canada right now, we are looking at anywhere from a $232,000 budget expense just for salaries in a 3-month period, all the way up to $928,650 if this custom development occurs over a 12-month period. We're assuming there are no contractors. These are full-time employees. There's no outsourcing, which promises to reduce costs but doesn't always do it. And this does not include cloud hosting charges, software tool and development machines, perks and benefits, cost of data, and so on. So you can see how expensive custom development would be. So, having said all this, the space sector's downstream challenge is increasing space sector activity and urgent need is leading to a massive increase in space data. Managing this data and building downstream software applications is incredibly complex, time-consuming, and expensive. It requires superior big data, web, cloud, and GIS software expertise, and globally, custom development has a high likelihood of failure of some level. So we think the space industry needs a way to quickly and reliably build space apps for all the purposes that we mentioned in the examples we gave earlier. We must have a way to quickly and reliably build space apps that handle 80% or more of the common and key requirements for a space app, that favors configuration over custom development, that decreases software project failure risk and timelines, that delivers high ROI compared to consulting and in-house development, and decreases total cost of ownership over the lifetime of the app. In short, we must move from artisanal space apps creation to mass production. So how do we get there? Well, we have new solutions on the horizon. We need a space app software factory. Mass production of space apps requires a software factory approach that uses little or no custom development to quickly and reliably build space apps, which meet the business needs and put space data in the hands of end users. And I think this is very relevant for the space industry. If we look at the picture on the right-hand side, that is SpaceX's factory floor where they're automating and reusing a lot of components. And I think that's a perfect analogy to what they're trying to achieve in the hardware space. I believe that's necessary on the space apps software side. So the concept is simple. You have the software factory that outputs a space app based on requirements. That uses space data, and it serves the business need. And the space app itself that's produced could be 100% standard with no customizations, or it could include some level of customizations. Obviously, there may be 100% customizations in some cases, driven by the business need, but you would not be using the software factory in that case. We're very confident that many, if not most of the functionalities that are required in a space app can be built at a standard level and produced by software factory. So what are some of these common features? Well, it would have to produce a scalable data lake for storing big data, have the ability to handle AI and Earth observation satellite image processing algorithms, provide geospatial software access, including web maps, GIS-aware databases, temporal and spatial metadata capabilities. We need to provide the data scientists with tools that they want to use. It must have a front-end web application for end users, back-end and middleware web services that can be integrated with, hosted on a secure cloud infrastructure that can scale, and allow publishing and packaging of analysis-ready and value-added product data sets. So why would we use a software factory? It's tailored to space industry downstream requirements and data types. It takes a standardized approach to satisfy 80% of end user needs. It favors configuration over custom development. It reduces development time, effort, cost, and risk. It increases return on investment, and it decreases total cost of ownership over the lifetime of the app. Why not use a software factory? Standardization implies some compromises. So you don't use one if you want to meet all of your business requirements in a highly specific way without any compromise. You want to use third-party components or features the software factory doesn't yet support and can't be easily configured for. You have a legacy solution you want to maintain that you cannot easily integrate. And you are willing to support the cost, effort, risk, and timelines of custom development. We believe that the software factory approach can help satellite data providers quickly embed data in customer software applications, create prototypes of new data product offerings and services, produce and publish data packages, tailor their data offerings for a wide variety of industries, customers, partners, and end users. We believe the software factory approach can help governments easily embed space and hybrid data in working software applications, improve end user adoption, compliance, and governance, improve system interoperability and maintenance, decrease software development risk, increase the return on taxpayer dollars, and maximize the potential of space-based Earth observation and other space data. And we believe the software factory approach can help GIS developers and ISVs more easily build software components for their products or their customers, increase productivity of their development teams, rapidly create prototypes and demos, improve market adoption of their products and solutions, improve technical interoperability and maintenance, and decrease software development risk, time, effort, and expense. So let's talk about Deploy's software factory project. Our Space App Software Factory is in development. We've completed 18 months of marketing and technical research, as well as R&D effort, and principal development is ongoing in Canada. We are currently working with several early adopter clients and partners to support their requirements in the factory. And the minimum viable product will be able to produce two common types of space apps that we've identified. You may be interested in our Space App Software Factory if you're a satellite data provider or intermediary who wants to embed your data into end-user software solutions at scale. You work for a government organization and want to maximize the potential of space-based Earth observation and other space data. You are a GIS software developer or ISV and want to speed up your development efforts and decrease your risk, time, effort, and expense, or integrate your product or service into a space app or vice versa. So in conclusion, space apps are software applications that use data from space and fit a certain profile. They are very complicated and are currently created by manual custom development efforts, which are expensive, long, risky, and costly. Increasing space sector activity and urgent need is leading to a massive increase in space data and the need for space apps. To unlock the vast potential of this data, we must move from artisanal space apps creation to mass production. And during a time of great economic uncertainty, when it comes to building software solutions, you need to do more with less. Mass production requires a software factory approach that uses little or no custom development to quickly and reliably build space apps which meet the business needs and put space data in the hands of end users. This approach might be especially useful to satellite data providers, government organizations, or GIS developers and ISVs. On the horizon is the Deploy Solutions Space App Software Factory, contact us to start the conversation. What's on the horizon? The future of space apps development. Thank you for attending the presentation. We'd love to hear any feedback or questions you may have. Please email us at spaceapps@deploy.solutions. You can also learn more about our company and the work we do at www.deploy.solutions.
Hey, Nick.
Hey, John, can you hear me?
Yes, I can. Thank you so much for that fantastic presentation. So interesting. We're so lucky to have you and Deploy Solutions with us for GeoIgnite for the first time. You're our silver sponsor. Again, we wouldn't be able to do this type of thing for the community without you. Everybody, use the Q&A tool in the Zoom system to put your questions in for Nick. Now, I was actually texted a question during your talk, so let me kick it off. So is your software factory based on data standardization or something else?
Yeah, that's a good question. So data standardization is a very important element of it, but we're thinking of the application as a whole, especially around the business needs. And so data standardization would be a element of a software factory approach, but there are other elements as well that are important. So the use of standardized tools, making them available, making the way that the code integrates with the tools available, all of that would be also a part of that solution, in addition to the standardized data.
Good stuff. I've got another one here. Do we use the software factory directly, or do we use the space apps?
So the intent behind the software factory approach is to produce the resulting space app. So if you're an end user, you would be using the space app with whatever configurations and components and data are available and required to meet your business needs. The software factory itself would be producing that outcome, that space app that meets your particular needs. And that would be something that we would work on with partners to make sure that we configure the software that they offer, the services that they provide, in addition to the core underlying capabilities that we offer to deliver that space app.
Thanks for that, Nick. So we got the Q&A starting to come in. The first one is from Ala. Hopefully I'm pronouncing that correctly. For now, you are building applications involving geospatial data. Do you have any plans to build applications involving astronomical images data?
Yeah, that's a good question. So to be honest, currently we don't have any particular plans to support anything apart from geospatial to begin with. It's not to say this approach could not be used for that. And certainly we're trying to build things in such a way that they're standardized where they make sense. But at the same time, we're not trying to meet every possible need. That's obviously the opposite of the software factory approach. So if it makes sense, to make this available for astronomical data because the functionality supports that, of course, we're interested in that.
Good stuff. So I'm gonna get one of my own questions in. We've got some more questions coming in, but Nick, you're obviously very passionate and doing a lot of community engagement. The hackathon. Go Geomatics, obviously, we do a lot of community engagement. Can you tell us a little bit more how you kind of got into where you found your passion for all of this?
Yeah, it's a good question. I've had it for a very long time. I can't actually point to a date where, I didn't feel passionate about the space industry. I can remember as far back as 2001 that I was actually, figuring out how to build a website for surfacing images from space. And so I've always had it, but I think I just decided about 8-9 years ago that I was going to start attending the Canadian Space Society's annual summit just for fun. I felt like I was there, the only one not working professionally. Maybe that was untrue, but I certainly felt like I was sort of the odd person out. But everybody was so interested, so friendly. They had such deep technical knowledge, and so that really galvanized my interest. And as a result of my attendance there, I ended up working with Ryan Anderson, who invited me to co-host and organize the Space Apps Ottawa event. And so this is our 4th year. And I would say that that was really a major turning point where I suddenly realized that there were people, young people, who didn't know how to get into the space industry, but wanted to solve space challenges. And that's what started my journey and the decision to pivot this company into the space industry. The knowledge that we could talk to scientists, we could talk to government people who were GIS experts, and we could try to solve business challenges. And that really, I think, is a major gateway for a lot of the conversations that we've heard all week at your great event. A lot of people are talking about ways of engaging underrepresented groups and the youth and so on. And I think that the hackathons are just an amazing way to do that. And certainly how I realized that I could actually deliver something professionally in this area, it was only because of attending those kinds of events that I was able to build up that confidence and that knowledge.
Fantastic. Well, we're all pleased that you found that passion and the excellent work that you're doing. We've got another question coming in. Our sector is adopting cloud more slowly than other industries. Why do you think that is, and how can deploy solutions help?
So I found that this is actually a challenging industry to get into. I've worked to a lot of industries around the world for a long time, and normally you can kind of skip from one to the other. There's a lot of good historical reasons why I think it's so challenging. Obviously, in many cases we're talking about lives and national security and very complex technology and science, as well as also government regulations and international laws and treaties. So I think that all of those things are obstacles to adopting new technologies and approaches, including the cloud. I think that I've seen that before. I've done a lot of work with the governments, in different countries, and if you always treat a technology or an approach like cloud delivery as something that you always have to use 100% of the time, that's actually the wrong way to look at it. So instead you look at this as a spectrum of capabilities. And so if you look at your functionality and your requirements that way, there are occasions where you can use the cloud. One of the challenges with cloud development as well, and just generally, is how complicated it is and how quickly it's changing. People are obviously worried about, security and privacy and, where the data gets stored and all that stuff. So I think that Deploy, we have a lot of experience doing this kind of work in other industries. We can definitely bring that expertise to the table. My personal expertise has been in that for a very long time. And I think the big value add we can bring is a new set of eyes. Let's look at the requirements that are out there. Let's not try to tackle everything. We're certainly not promising that. But let's look at the 80% or more that's probably useful for everybody. And where it makes sense, let's try to adopt that. And so you need to marry that kind of knowledge with a deep technical expertise. And I guess the other area that we can help is we have a tremendous amount of experience working with partners. We believe very strongly in best-of-breed partnerships. And so I think that there's an opportunity here to work with other people and to bring their technologies and their capabilities into this overall holistic solution, and let's deliver it on the cloud if we can.
That's fantastic. If you could follow up, what do you think makes a good partnership in this area?
I think what I've done in the past, and I think it would probably apply here too, is, again, you look at the business need first. What are we trying to do and how are we trying to do it? And you try to deliver the capabilities, as best you can, but you don't want to reinvent the wheel. If there's a partner out there that has a great reputation, they're well established and they have some good ideas and they have great technology, you look at a way to integrate that. So you complement what it is that they offer. From a technical perspective, you make sure you can integrate with it, you make sure you can deploy it, and you build that relationship over time. And so I think that that's also one of the reasons why it took me a while to understand I could take my passion for space and do something more professional with it. But I really felt that I could take a lot of that experience that I had in other industries, including these best-of-breed partnerships. And what you do with a best-of-breed partnership is you're not constantly looking for the next best thing. You're actually building this relationship, and you're getting to know the people, and you're proving that this is going to work through working together. And that takes time. So I would say that another thing that we can bring to the table is that this is something that we've been interested in for a very long time. We're doing the hard work, we're making the connections, and we're working with people, and I think that that's going to pay off.
I don't want to put you on the spot or anything, but can you tell us any specifics about any partners that you're working with and projects?
I've got some projects that we're going to publish on the website. We're in early partnerships with a number of organizations. One of them is actually a European new space partner. We've also worked in partnership in Canada for a Canadian government client. We're a subcontractor, and we're continuing conversations. So I am going to dodge your question because I don't think
okay.
I've got any kind of.
I know how sensitive that can be. Yeah, no, that's fine.
You know what? It's something that we're going to have to do a better job at actually, putting that out there publicly. But for now, it's just something that I haven't formally signed off on with them yet. So I'm respectful of that.
For sure, definitely. So we've got a kind of they describe as a silly question, but I think is fun. Have you met Chris Hadfield or any other astronauts, actually?
I have not met Chris Hadfield, but I have met other astronauts. So I met Dave Williams at the Canadian Space Society Summit when he was presenting his book. Strangely enough, I was at the summit again trying to learn about space, and my aunt showed up. She was actually helping him to publicize his book at that event. So I ended up getting a signature and getting a chance to meet him. He's a wonderful person. I also saw Jeremy Hansen at the Planetary Society Summit celebrating Canada's 50 years in space at University of Toronto. And I've watched the Chris Hadfield music video a few times, but I haven't met him yet.
Yeah, we had a lot of fun at your social last night. Thanks so much for doing that. And the prize that you gave out was a lot of fun. It was a shuttle? It was a model of a shuttle, wasn't it?
I'll almost say it was the SpaceX Crew Dragon, 3D printed. It's kind of one of a kind, although we're probably going to, it's 3D printed so we can produce some more, of course. But yeah, it was kind of a celebration of that launch that happened earlier this year with Bob and Doug to space.
That's fantastic. We're coming up to the close, but we still have some time for more questions. I'm curious, in your presentation, you talked about some particular relationships that you thought would work well. I saw satellite companies, government agencies, departments, as well as GIS developers. As a GIS specialist, or I used to be, now that I kind of do the public-facing stuff more, can you describe a little bit more about how a GIS developer might be able to work with you?
Yes, I think that's a great question. And so it's important to note that we're trying to be very practical. And in order to standardize and to deliver rapidly, you have to make disciplined decisions, right? And so we're not trying to be all things to all people. So, that's the first filter. We also recognize that there's an enormous amount of GIS expertise out there. There's some great products. There's some great applications that are being built. We're not trying to replace any of that. We think that that knowledge and that expertise and that IP can be applied more effectively and more rapidly if the number of things that the people doing that kind of work have to do are narrowed, because a lot of the grunt work required to set up a cloud infrastructure, for example, or to make sure there's automated testing or deployment scripts is already handled through the standardization. So we actually think that if you looked at a spectrum from 100% standardized to 100% customized, our software factory could provide 100% standardized. It seems a little unlikely because everybody always has a slightly different business need. There'll be some level of customization required, and how much that is depends on the client and what the software factory can and will do. But there's a space in there for sure for best of breed partners, which would include these GIS developers. And so that's why we think that there's a tremendous opportunity here. We've heard from experts all week, and there's other people out there that we'd love to talk to and figure out ways that we can remove some of the hard work and some of the rework that always has to be done per application with our software factory and allow them to shine in terms of their customization.
Fantastic. We've got more of a statement than a question from Billiana. Great presentation, Nick. Thank you for promoting diversity and inclusiveness in our geospatial ecosystem. And thank you for organizing these hackathons and supporting young leaders finding their passion.
Thank you so much for saying that, Billian. And I'll say also, we've been working with a number of universities, actually 20 of them, academic institutions over the last year on a climate change research project. We're going to be publicizing those results shortly. We also talked to 100 Canadians coast to coast to get their impressions on problems in climate change and how software could solve those. And every time we talk to people, our passion was sort of renewed. So it is a lot of work and a lot of time that goes into these events. And certainly that shouldn't be, discounted, but it doesn't really feel like work because there's such interesting people out there, and so this is how we make our passion kind of a renewable resource. And again, for anybody listening, this week, worried about or wondering how to talk to young people and improve diversity and so on. We believe that the International Space Apps Hackathons are really a good way to do that. So we strongly encourage you to get in touch and see how you could assist or promote those.
Thank you. So just to close this off as we're finishing now, if you want to get in touch with Nick and learn more about what he's doing, hackathons, and the factory solution, we've got links on the GeoIgnite website. We're also got a Slack channel. I think, Nick, you've been in there. You can probably engage with Nick on that, but definitely on the GeoIgnite, go to the partners and the sponsors page. So Nick, thank you.
Thank you so much for this event, John, and Tessa and everybody who's involved with it. It's a pleasure to be involved in any way.
Best to you. We'll see you hopefully in person in the future, and good luck with all your projects. We hope to see more, and we'll engage our Go Geomatics community with you and your community.
Thank you so much.
Thanks. Bye-bye.